Ladies and gentlemen, a very warm welcome. First of all, to the people I can see. There's a few more in the overflow room, and there's about 500 at least online. I haven't counted them, but I'm told that's the number. So welcome to the 15th Peter Lindsay Memorial Lecture. 16 years ago, Professor Peter Lindsay made a very generous bequest to make possible two activities. One, provides support for students who unexpectedly find themselves in difficult circumstances. That support continues to this day, administered by the Independent Charitable Trust arm of the City and Guilds College Association. The other activity is, once more, taking place this evening in the form of the 15th Peter Lindsay Memorial Lecture. Some of you may well be unfamiliar with Peter Lindsay, in which case you'll be able to learn something very interesting about his career in the brochure that I hope you've got. There's two very readable essays about Peter in this brochure. Tonight's lecture addresses a vitally important topic, namely the effect of the media on public understanding. The importance of this topic was, of course, evident from the media's reporting, selective though it was, during the COVID-19 pandemic. We would be, I think, seriously remiss if we did not address this topic in the context of future pandemics. I'm sure there will be some. And that our speaker this evening is well aware of the problems associated with the media's involvement, as reflected in the title of his talk, Can We Trust the Statistics in the Media? So it's my pleasure to warmly welcome Professor Sir David Spiegelhalter and invite him to deliver the 15th Peter Lindsay Memorial Lecture. David.
Thank you so much, and thank you very much for this kind invitation. Pretty terrifying watching the previous speakers in this series. I mean, they actually know some science, and I bet there's people here who know some science. I don't know any science, and so, so I'm going to talk about stats, which is an easier thing to talk about, I think. Just a conflict of interest. I'm all this stuff, but I'm also non-executive director on the UK Statistics Authority, which is the body that runs the Office for Statistics Regulation, Office for National Statistics, the Census, and all that stuff. So I will say that our British statistical system is wonderful, but that is a conflict of interest. I would say that, wouldn't I? Just a bit of background. I'm very grateful for the Peter Lindsay benefaction to enable me to give this lecture, and I hope have a couple of drinks afterwards. So that sounds great, because I'm a great fan of benefactors. Yes, you know, we all need one, I think, because I used to do this sort of stuff, Bayesian analysis and Markov chain Monte Carlo and things like that, and about 15 years ago, I was getting pretty fed up with it all, writing papers, referees, oh my God. Had enough of that. And so I was very fortunate to be philanthropically funded in 2007 by David Harding, Winton Capital Management, who's got, you know, a lot of money, and he gives it away, and some of it to me, which I thought was extremely kind of him. And so that enabled me to essentially change my career and completely shift, retrain, I suppose, as a performing statistician. and, go on to television and make documentaries on BBC4, get on Anandpur talking about statistics, write popular books after statistics, which has done well. I mean, I was writing unpopular books. Yeah, you know the sort. They take years to write and don't make any money at all. This one took years to write and it's made money. You can make money, so that's quite nice. Since then, with Anthony Masters, we've written COVID by Numbers, again in that Pelican series. And over COVID, I did a lot of media stuff. There's a huge demand for statisticians, which I'll talk about in a moment. But it was an exciting time, quite a challenging time. But actually, my only reason for doing it was this. It was to get on desert island discs. And now I've achieved it, so I don't have to do anything else anymore. It's great. Life's ambition just fulfilled. There it was. So I got on desert island discs. You can see my smug expression. Look at this. I've just fulfilled my life ambition. Yeah, awful. Okay, so I'm going to talk about statistics in the media. I'm going to put up a whole lot of examples, ridiculous examples. You might be familiar with some of them. And it's just to sort of give a flavor for the way in which statistics, what we see is, chosen for us to see it by somebody. So I always like, it depends on the audience. What stats do you see? So this is one of my favorite graphics of all. These are just, 1 year, a sample from 1 year front pages from the Daily Express. Busy roads can cause dementia. Snoring raises dementia risk. Dementia risk can be eat curry to beat dementia. Now, this says, you notice the topics? There's a certain sort of common theme. This says more about the readership of the Daily Express than it does about what's important in science nowadays. And you'll notice always that they're really, actually, now look, snoring linked to Alzheimer's. That's quite fair. But this is snoring raises dementia risk. So you see there's a different interpretation there. One is in terms of a causation, one's in terms of correlation. Because we know that correlation is not causation. I stole that picture because I think it's a really nice example of this. Yeah, and but we see this all the time. Now, where does that sort of misrepresentation arise? And various places where it can arise. So this was a study, spectacularly dull study. It's the sort of thing they do in Scandinavia because they can link. Amazing, because everyone's got a personal number, so they can link education with health records, with income, with their tax records, and they can put all that together in a great big epidemiological study. And because they're very trusting in Scandinavia, nobody objects to all that. Anyway, this is a study. It was done with University College in London, and it found consistent associations between higher socioeconomic position and higher risk of glioma. Richer people got more brain tumors. Now, why might that just be an artifact, not causal? Live longer, yeah, absolutely. First thing, they did age adjust. So the very first thing is you've got to age adjust. This was a Cox regression, adjusting for age, so they counted that. Why else? Yes, richer people get better health care. They get more diagnoses because they seek better health care. We know that. And the authors said that. This could be an artifact just due to ascertainment bias, as they'd say. Okay, but the press office got hold of it. They thought, oh, this is good. So in the press release, it said, high levels of education linked to heightened brain tumor risk. Now, that wasn't what the study was about, but never mind. So that was the press office, and I think you can guess what's going to happen next. By the time it got to the Daily Mirror, we get, why going to university increases the risk of getting a brain tumor. So just you watch it, you students, is all that thinking. It makes your head heat up or something like that. No. So we notice that escalation from changing the topic from what it was, that study was actually about, from association becoming causation. Just done like that. I should say the article underneath that was okay. It's the headline writer. First thing to realize, the people who write the headlines are not the people who write the articles. They're the sub-editors. After the journalist has gone home, the headline goes on, and it's clickbait. We're going to see this again and again. Okay, so that's one of the first things. But there's a couple of lessons there. First of all, the press office needs to be kept under control. The scientists, you, as scientists, you need to work with your press office and make sure your work is not being misrepresented. Okay, this is my favorite correlation. Fizzy drinks make teenagers violent, from the Telegraph. Pretty causal language there, but it's a cross-sectional study. They went out to all these American teenagers and said, how many, sodas do you drink a day, and how violent are you? And everyone ticked the boxes, and they found this correlation between drinking more sodas and being more violent. And I think, well, there is this thing called reverse causation. I mean, maybe after a hard day's violence, you get thirsty. But no, that wasn't, they didn't have that interpretation. Again, correlation, not causation. That's the headline writer again, doing it there. But maybe it's not just the sub-editor, maybe it's not the press officer, maybe it's the scientists themselves that distorts what gets in the media. So I've become very skeptical about quite a lot of scientists themselves who have their agendas. And they may be for the best possible reasons. Do you know this term white hat bias? Lovely, it's on Wikipedia, so it must be true. White hat bias are people who feel it's okay to be economical with the truth because they're goodies. They're on the side of truth and righteousness. So it's all right to bend things. So that's white hat bias. Here's a lovely example. Apocalypse warning. Urgh! Insect population must be saved or life will disappear. This is a great headline. I love it. Okay. But The Guardian, more than 40% of insect species are declining. Total mass of insects is falling by a precipitous 2.5% a year, according to the best data available, blah, blah, blah. This was a report of this study, which was, they didn't do original research, it's what's called a meta-analysis. They searched the literature, put all the studies together and came out with these estimates of the 40% decline. Now, these in some sense were very good scientists in that they did report their methods. So in the paper, you can actually see the search terms they used for the literature. And these were the search terms. They searched for insect and survey and decline. So they only looked for papers about declines. So they were finding the evidence to suit what they wanted to find as the conclusion, which, of course, many people think that's research. And in fact, my colleague Kevin McConway did the same search term with increase and got even more publications. So that was, and they were completely unapologetic about this. Absolutely, this was a more or less story. They were totally unapologetic about it. We've got to alert the world. Yeah, but this doesn't do the reputation of science any good at all. Okay, the importance of framing. I spend all my time working with psychologists now and social scientists, and we know from our work with Kahneman and Tversky how easily our emotions can be manipulated if we think fast. We just respond emotionally to what we're exposed to. So framing is terribly important. This is one of my favorite examples. This is another staggeringly boring paper with masses of authors saying 10% of people have got a genetic variant that reduces the risk of high blood pressure. So that's a positively framed story, pretty tedious, until a brilliant press officer got hold of it. Out for an award, I'm sure, and switched the story to 9 in 10 people carry a gene, which increases the chance of high blood pressure. That's perfectly logical. You just recode 0 and 1 to 1 and 0 in your analysis, and you've flipped it to a negative frame. Headlines around the world, loads of, you can still find these stories and things like that. Really clever. Awful, really appalling, but very clever press office work then. So the framing is terribly important. 2% mortality rate sounds a lot worse than 98% survival, et cetera, et cetera. We know these stories. This is one of my favorites. This was a media campaign on the streets. I took this photograph of it. It was the 99% campaign. 99% of young Londoners do not commit serious youth violence. So that's a positive frame to influence our opinions. Well, we've been wrong about these young people. Hug a hoodie. We've been completely manipulated. We're completely wrong. Until you stand there and think slowly about this, and there's 2 tricks that you do to change the entire emotional impact of that story. The first thing, you can guess, what's the first trick? 1%. Yeah, is a positive frame to negative frame, just as I showed. So that means 1% of young Londoners do commit serious youth violence. What's the next trick? How many? Exactly. So there's about 8 million people in London. There's actually about 1 million between 15 and 25. Let's call those young. 1% of 1 million is 10,000. Oh my God, there's 10,000 violent young maniacs roaming the streets of this city. They didn't put that on the poster. So these are neat tricks. I always think I shouldn't be teaching everybody these but actually you do need to learn them and kids should learn them in school in order to identify when it's being done to them. How their emotions are being manipulated by the way the story is being told. The numbers don't have to be made up in order to manipulate your emotions. Okay, so let's see about COVID. Let's see what's been going on in COVID. It's been a very busy time. As I said, with Anthony Masters, we had a column in the Observer every Sunday for the whole year. We did 50 articles on COVID stats. Only like 350 words, no graphs, no jargon, very few numbers, no maths. So it was very challenging indeed. And I'll show you, I'm going to give you one of the challenges in a moment that we had. So, but it was good, it was good. So one of the articles was just simply about reporting how many people have died from COVID. Now, that is not a straightforward question at all. There's at least 6 different definitions I could come up with on the spot for that. But media coverage of the COVID stats, I think it's generally been pretty good. It's actually been, I think, been very good. They've learned fantastic data journalism from John Byrne Murdoch in the FT in particular, and in The Economist, and The Spectators. They've been doing good data journalism. And even the Mail and things like that, there have been graphs all over the place, and they've been pretty good on the data, with exceptions. With some exceptions. And this is the one that absolutely drove us and everybody else mad, is that just deaths within 28 days of a positive test. Okay, so this is reported every day. Now this is the smooth curve. This is by date of death, the actual date in which people died. And it's smooth. Now I won't talk about whether that's a good measure of death, because this includes people who were knocked down by a bus 3 weeks after they tested positive. But it cancels out because it doesn't include people who lived more than 4 weeks and then died. So in fact, for quite a long time, those were roughly cancelling out. So this wasn't a bad measure. So anyway, it's nice and smooth. Compared, if you look at it by date reported, in other words, the date that number is reported on the news, that's what it looks like. Hugely spiky because hospitals don't send in their returns at the weekends. Most of them don't. So it's really low on Sundays and Mondays and shoots right up on Tuesdays and Wednesdays. Now, everybody, by March, well, certainly by April, everybody in the trade knew this. The good journalists knew it. Everybody knew it who was working in this area. You can't trust these daily figures day by day. Smooth them and it's fine, but not day by day. But some journalists, of course, never learn. A general journalist wouldn't pick that up. And the Evening Standard, oh, this is just so amazing. Look, here we are, 3 headlines. COVID deaths soar to 146 in deadliest day since March. UK COVID deaths soar to 262. Coronavirus deaths soar to 170. So what do we learn from that? First of all, they should get a new sub-editor, or at least change their language a bit, these repetitive clickbait headlines. But the other thing that really links these stories, apart from the language, is that they're all on Tuesdays. This is a Tuesday effect. This is a totally fake story because it's a Tuesday effect. And yet they kept on writing that story again and again and again. So what I say is the media, that's a problem, again, with unskilled journalists looking at the data. So we've got problems going to arise with the scientists, with the press officers, with the journalists, and with the headline writers as well. All the way through this stage, problems going to rise, and we need to work on all of these things. Okay. Government communications have not set a great example sometimes. Can you remember that one? I mean, you're a very technical audience here. I'm sure you'll appreciate a really meaningful equation like that. That way we find it so easy to interpret. What is it talking about? It's complete nonsense. Okay, but somebody in number 10, comms department, thought that was a great idea to put that into a press briefing. This is one of my favorites. This is, okay, is this a log scale or not? There's absolutely no way of telling from the graph itself. It is, in fact, because, again, my friend Kevin showed you, this is just knocked up in Excel. just that. You took the data, shove it in Excel, and you get these reasonably straight lines showing exponential growth in the different countries. So a ghastly graph, great spaghetti of numbers. You can't see who's who. Awful, awful in almost every way. It's fine to use log scales. They can be very useful for interpreting different rates of exponential growth, which otherwise are very difficult to see on the lateral scale. But not like that. So that was in the winter plan. Okay, what about this one? Cast your minds back to this amazingly contested time, autumn 2020. No vaccine. You know, there were vaccines where we knew the trials were going on. We thought they would be on the horizon, but absolutely no promise that the vaccines would be coming up as quickly as they did. And yet cases were rising, calls for interventions, highly contested, because we just had the summer, we just had Eat Out to help out. We had this lovely summer, and were we going to lock down again? Were we going to, et cetera, et cetera? And the advisory groups by they've got different modeling teams. There's, I think, 5 to 4 different modeling teams there, from all making projections. The blue one is the Cambridge team at the MRC, and they came out with these projections. Now, look at the communication, which is quite interesting. They say these are scenarios, not predictions or forecasts. And they said that till they were blue in the face, but nobody listened. And these are scenarios, and they're completely unrealistic scenarios, because they assume nobody does anything as cases go through the roof and deaths go through. We're all going to sit there without changing our behavior or do absolutely nothing. So you know this is not going to happen, even without any rules, because the effect of lockdown starts before lockdown, because everyone changes their behavior. And we know people will change their behavior once those sort of stats come in. So this would never happen. This would never happen. So it's quite clear that these are scenarios, not predictions or forecasts. The other thing which people point out was that this got leaked. I don't know if you remember all that. It got leaked in advance. They weren't going to show it, and then because it was leaked to the press, they had to show it. And this MRC one had already been withdrawn because it was already uncalibrated, and it had changed. Already it was out of date. Anyway, so this caused a lot of fuss and some interesting headlines. You know, coronavirus, more than 4,000 deaths a day unless there is a second lockdown, scientists warn. Again, that assumes 4,000 a day, assuming very pessimistic assumptions and assuming that nobody does anything. Then, and then the Daily Mail had a go at it. There's 4,000 deaths a day. Forecast of 4,000 deaths a day. They call it forecast and say, oh, it's completely unrealistic. And it's true, it is really unrealistic. But they did say it's a worst case scenario. So again, they call it a forecast. It's not a forecast. But the communication of what it was, completely unclear and very bad. And they got told off by my regulator. You know, this is, so I got a conflict of interest here. The number 10 got told off for using that graph without fully explaining what it was about. So there's a public telling off there. So what's interesting, though, what actually happened, of course, there was a lockdown, and yet deaths reached 1,200 a day in January 2000. So actually, with a lockdown, it got to there, which isn't, you know, and these were no lockdown scenarios, and this one had come down. So these were quite reasonable models, in fact, quite reasonable. But they got an absolute hammering for that. The bad press coverage because of bad communication by number 10 and by the scientists themselves, I think. Okay, so let's look at another problem. That's a complex table, you don't need to look at that. The crucial thing is, in middle of June 2021, it was first observed that the majority of people dying from COVID had been fully vaccinated. So here you've got a column. This is deaths in each age group. This is not vaccinated. You notice it goes up to a maximum of 157. These are deaths 14 days. Second dose, was more than 2 weeks before. Goes up to 1,300 of older people dying from COVID. So in the older age groups, the huge, overwhelming majority of deaths were in people who are fully vaccinated. Okay. Immediately, that was greeted by, well, you know, this is terrible. It shows vaccines aren't working. They're killing people, things like that. Okay, let's have some quick thing. How would you explain that to your skeptical brother-in-law who says vaccines are killing people? So, any quick, yeah, quick.
Well, I presume that a lot of people have got
small proportion of a large number can still be bigger than a bigger proportion of a small number. I've tried that one, that language, but no, you're absolutely right. Anyone think of a way that this is, I mean, it's Bayes' theorem, in fact, you've just got a large number of people. Can anyone think of a story that you could use, an analogy that might work? Have you seen this one? What? Yeah, I think the pie is probably a good one, yes. A small pie. You've got a huge pie, you take a little section, you can still get more than if you've got a big chunk of it. Yes, that's quite a nice one. I like that. I like the pie idea. Yes?
Well, I've heard it likened to a number of people wear seatbelts.
That's it. I wish I'd made that up. I stole that one, the one I use all the time. Most people who die in car crashes are wearing seatbelts. It doesn't mean they're not effective. It just means that most people are wearing a seatbelt and they're not perfect. So the breakthrough deaths outnumber the others. So we tried to explain this. Anthony and I, we spent ages trying to get 350 words to do this, to explain why it's the case. Don't think of it as a bad sign, exactly what expected from an effective but imperfect jab. This was not appreciated by some. This was, one of the tweets we got. David Spiegelhalter, Anthony Masters, and the entire lying, genocidal editorial board of The Guardian should be hunted down and destroyed for crimes against humanity. Period. That's a bit nasty. And Anthony replied, that seems harsh. I thought it was a good article. And then I came in, perhaps a bit harsh, but I've had worse referees' reports. And for those of you who know about submitting referees' reports, you know the sort of thing. So this started off a whole meme on Twitter with people saying, referee 2 thinks you are genocidal and should be destroyed. I therefore ask revisions and further submission. So anyway, we can laugh this off. We're men, white men, we got a certain amount of abuse, and this was considered a threat. They got banned from Twitter for threats. We didn't report them, someone else did. So we've actually managed to avoid a lot of the unpleasantness that other people have been subject to, but also partly because we deliberately set out not to take sides. We weren't saying what should be done, and that saves you from a lot of abuse. If you genuinely try to stick to explaining things rather than saying, going from one side or another, rather than telling people what they should do and what the policy should be, which isn't our job. We're not qualified to do that. I wouldn't dream of doing that, or try to avoid it. So what happened with that data? Here is President, you notice that table I showed you? There it is. President Bolsonaro using this UK data, claiming that, if you read Portuguese, you'll be able to translate it, but basically he's saying the UK data shows that the vaccines are killing people. So this was awful. And a Trump advisor used the UK data to argue the vaccines were really harming people and so on. Again and again, this data being provided in good faith by the UK Health Security Agency was misused around the world. Still being used. Here we got, again, the stats watchdog, conflict of interest. I'm on their board. Told them off for allowing this data, not being clear enough about the limitations of this data. And look at this, GB News. God, does anyone watch GB News? It is absolutely ghastly. It makes Fox News look reasonable. So anyway, here we are. Government's own data holds up the graphs, show triple jab are 4 times more likely to die from COVID in Singapore. Vaccines are killing people. Still this data is being wheeled out to show that. This is really disastrous communication. Okay, so coming to the second bit of the talk, it's about, I focus all the time on trust. It's absolutely vital. And if you start talking about trust, can we trust the data? We go to Honora Neal, Baroness Honora Neal. Her Reith lectures on trust are still staggeringly brilliant. Her TED, I don't like TED Talks, but she is brilliant. 9 minutes she's got on TEDx Parliament. It's trust, it's Kant, she's a philosopher, and jokes. The whole lot, 9 minutes flat. She's brilliant. Anyway, she's got a bit of wisdom. She's a sort of, I think it shouldn't be, she's a sort of clickbait philosopher. No, that's not true. She's a soundbite philosopher. She managed to distill her wisdom over decades to really pithy, and I'm going to use 2 slides, best 2 slides of the whole talk, or just how she has managed to distill her understanding. So her understanding, what she says, is that organizations should not be aiming to increase trust. And we get asked all the time, well, how can we make people trust us? You know, everyone wants to be trusted. You know, government wants to be trusted, no one else wants to be trusted, and things like that. She said, wrong. You're answering the wrong question. This is the philosopher of Kant. I haven't read any Kant. Apparently it's all about duty ethics. So she says you have a duty, instead, to demonstrate trustworthiness. So the responsibility is flipped right round. Rather than the responsibility of, the masses out there they should be trusting you, and how can you manipulate them to trust you? No, the responsibility is put back on yourself to be trustworthy, to demonstrate it. It's a duty, it's an ethical duty. It's a really powerful thing. I go around ranting at corporations, things. No, this is, don't try to be trusted. Try to be trustworthy. Really powerful idea. And it's had a huge influence. Code of Practice for Statistics, which again, this is the body I'm on the board of, so I would say this is great. I wouldn't say it's riveting reading, to be honest. Unless you do suffer from insomnia, it could be useful, but it's unbelievably important because it's the code that permits, public bodies and the Prime Minister, Boris got told off repeatedly because of breaking in the way in which official statistics are supposed to be used. The number one pillar in the Code of Practice is trustworthiness. This is a direct influence of a philosopher, of Honora O'Neill, on the statistical system of this country. That trustworthiness, along with quality and value, the TQV system is what underlies the entire national statistics system in this country. Really powerful. Trustworthiness. So, how can we be trustworthy? We wrote an article in Nature, 2020, in the middle of the pandemic, just after that October one, where we tried to take Honora's lesson of trying to boil, rather than a huge essay, boil it down to a few bullet points. And this is what we came down to in the end, things we thought were important. First of all, that you should ask yourself, are you trying to inform people or are you trying to persuade people? Now, just be honest. Sometimes you're trying to persuade people. You're trying to sell them something, trying to get them to vote for you, trying to maybe even evacuate, maybe even get vaccinated. Possibly. Some people might feel, or in public health, might feel it's fair to try to persuade people. But you've got to be honest about it. But a lot of people actually say, we're just trying to give people the information. But no, their performance indicator is how many people will do something. And once you are measuring success by what people do or think, you are not trying to inform them. You are trying to persuade them. And you've got to just be honest about it. Because if you're not, if you decide you're trying to inform, which I think you should be most of the time, it changes the whole perspective. First of all, you've got to be balanced. You've got to show the benefits and harms, the winners and losers. Doesn't mean 50-50. It's not like climate change, yes, no, ooh, let's vote for it. No, this is, but we have to be balanced. We have to be upfront about uncertainties, give ranges, etc., on any numbers we're given. We have to admit when we don't know, when the quality of the evidence is just not good enough to be able to be confident about a claim. And this is the other one, which I haven't really got time to go into. But we've got to also come in really hard on misinformation, quick, early. Not to be on the back foot, not to be in there, not to try to avoid it happening. And also, we've got to teach people the tools to deal with it. They recognize the tricks that people use for misinformation, kids especially. So those five, they're really powerful ideas. So I'd like to try to illustrate one of the problems, because this is quite a technical audience, so that's why you're getting a bit of technical stuff now. One of the problems with communicating uncertainty. Now, during the pandemic, SPIAM, great committee with the modelers, good people, they had 8 different teams estimating R. R, the average number of people get infected for each person. 8 teams independently, but they're estimating the same quantity from essentially roughly the same data. And here are all their estimates. Here's 8 numbers. The intervals hardly overlap. So it's their estimates and their interval, their claimed uncertainty, they're not overlapping much of the time. They can't be right. They can't. It's impossible that those intervals can be correct. So this is a real danger. They're far too narrow, these intervals, because they're model-based. They're each based on assuming their model is true. But we know their model isn't true. All models are wrong, but some are useful. They're far too confident. And what if we only had one team doing this? You know, it would be hopeless. So actually having multiple independent teams is enormously valuable. And then they all get together and they cook up a composite. And that's what we hear, which is good. But bless them, they do publish this. This is all public. Really good. Great communication that it's there for us to see that just as well as 8 of them doing it. So I think that as a modeler, someone who does, you know, we always used to work on Bayesian analysis, estimating intervals. Now I don't believe any interval, I'm told. A basic thing, I don't believe any interval, because it's based on assuming the model is true, and we know the model isn't true. So how can it be right? So that's one of the first things. And people have really learned this. This is, again, a very complex slide, but this is from UK Health Security Agency communicating about vaccine effectiveness. This is Delta up there, Omicron up there, and this is how long since you had the 2nd or 3rd dose, and their effectiveness against infection, symptomatic disease, hospitalization, and mortality. And you notice a few things. First of all, there's quite a lot of cells where they just say they don't know. They haven't got enough data, insufficient data. When they do give an estimate, they don't give an estimate. They only give a range. And the final thing I want to point out is that they believe some of those ranges are better than others. They actually then code them, high confidence, medium confidence, and low confidence about these. So this one actually got low confidence in that, but high confidence in these. That was from some time ago, so those will have changed. But you notice what they're doing. There's uncertainty being communicated in many different ways. And particularly this confidence measure, I think is very powerful. And I'd just like to say, I've taken this on board completely in all the work I do. It's enormously liberating to do an analysis and then publish it and then say, yeah, it's not very good though. Hugely liberating. So I'm on the team, the expert team for the infected blood inquiry. This is our report that came out a few weeks ago, and we're going to be interrogated about it in 2 weeks' time. And we were asked to estimate all sorts of quantities, like how many people with haemophilia got HIV through blood products in the 1970s and 1980s. It's about 1,250. But then with those numbers, we give a confidence statement, our judgment to the extent that the available data can answer the question of interest. SAGE were doing this as well, using this low to moderate to high, and high scale. A subjective judgment, qualitative judgment, about whether we can even answer the questions. So, for example, we were asked how many people were infected with hepatitis C through blood transfusions in the UK between 1970 and 1991. So the inquiry asked a team of statisticians for that. So we worked on that for 3 months, great team, doing all sorts of Monte Carlo analyses and really complex modeling and things like that. And we said, well, we don't know really. Well, no, we said, you notice the uncertainties? I think we kind of probably might have only used 2 significant figures, but only 3 significant figures, so lots of rounding to the numbers. Intervals, very wide intervals. Uncertainty intervals. And then only moderate confidence that we can answer the question anyway, because this is all based on a lot of assumptions in the Monte Carlo analysis. We could give high on some things, HIV in people with haemophilia, we get high confidence. Hepatitis B, low. No, we just don't know how many people were infected with hepatitis B, and we're not going to say. So this is hugely liberating, I think, and a very powerful thing to do. Copied from, it's very similar to what the climate change people, IPCC, they have a confidence scale, and so on. So, now I should come to an I'll come to an end very soon. Balancing benefits and risk. I suppose I'm trying to, I showed you some awful stories at the beginning. Now I want to show you some good ones. Here's a good one. I'm really proud of this one. Can you remember back in April last year, April 21, all the fear and anxiety over blood clots from the AstraZeneca vaccine? Macron was saying stupid things, other countries were banning it, and so on. And we were sent the data. Jonathan Van Tam was due to give a briefing to the public and the press on the Wednesday, and Alex Freeman and John Aston and I got all the data on Monday about the risks, about the blood clot data by age group. So we could fit that. We fitted a Poisson regression to give a rough idea of the age-specific risk. We also, John already had a model for the risk reduction in intensive care admissions over 4 weeks. We included that. And we ended up producing this graphic. Actually, there were 3 of these. This is for low exposure risk. We did it for medium and high. But it was a time when there wasn't much virus around at that point. The crucial thing about this is that it tries to treat the benefits and the harms of vaccines with equal emotional salience. Even choice of color is quite subtle. No bright reds. And no little people, blobs. No little people. Don't want dead people. And so it's just a general principle on communication. But we had to illustrate there's lots of stuff there. The fact that age is the overwhelmingly dominant factor about the benefits of vaccine because of COVID risks change so much. So that in terms of the benefits, in terms of reducing the risk of going into intensive care over the next 4 months, for my age group, you know, they're really large. But for young 20 to 29s, it's pretty minimal. It goes down really fast. But the risks go up as you get younger. So if we look at the trade-offs there, for people my age, whoa, pretty good, stab it in me, I want it. But it's not the case for the under 30s. So Jonathan Van Tam, bless him, we gave him this graph as a sort of aid, you know, just to help with our understanding of it. And he used the graph on, I mean, maybe just didn't have time to do anything else because he only got it about an hour before. But he used the graph on the television, on the presentation to the public. And I thought, he put it up and I thought, oh no, he's not going to try to explain that, is he? This was to explain to him. And he did, and he went through the graph, this very complicated graph, being very clear because he really understood it. He's a very trustworthy person, and people trust him. Took them through it, treated them with respect as if they're intelligent human beings, and then came to the end and say, so we're recommending that people under 30 don't get the vaccine. And everyone said, yeah, fine. No complaints whatsoever, no fuss about U-turns, no, oh, you're endangering them, nothing, no pushback whatsoever, completely accepted. Sun headline, you know, the next morning came up. It's not exactly the headline I would have used, to be honest, but... And that graphic then was copied by the European medicines agencies and all sorts of other things, translated in different languages, things like that. So it was done under huge pressure, but it was trying to put into practice the principles we were illustrating. So just very last little wisdom from Honora Neal. For those of you who are communicating, she's got a great thing about transparency. This, again, trustworthy, part of being trustworthy, being transparent. And this is one I love to use, because this is one I use all the time in my thinking. Whenever I'm trying to communicate about numbers, when we were trying to do our report for the infected blood, we thought about this all the time. What she calls intelligent openness. You've got 4 criteria you should be looking at. You've got to make your conclusions, the data, the inferences accessible. People have got to see it and be able to get at it. That's quite easy now. People have got to be able to understand it. It's got to be intelligible. And you've got to check that people can understand it. Avoid the jargon. Check the language is right. Check the graphs are clear. Check everything is all right. Then it's got to be usable. This is one of the tricky ones. It's going to answer the questions of the audience. Even if they're not things you think are particularly important, it's got to suit the audience. So that means if you're communicating, first rule of communication is to shut up and listen. Second rule of communication, it's like Fight Club. Second rule of communication, shut up and listen. So it's really important to know what the concerns are. We've tried to do that with the infected blood. And then the final one, you might think what's left, the final one is the most valuable one of all. It's got to be accessible. People should be able to check you're working. They shouldn't have to take it on trust. Now, nearly everyone will, but they should be able to check you're working. You need the appendices, you need the websites, you need the details, you need the code if necessary. It's got to be checked. Somebody should be able to do that, because that is trustworthy, even if nobody looks at it. At least you've done it, made that effort. Okay, so my conclusions. Trustworthy communication, vital to all stakeholders, and ideally you should be trying to inform rather than persuade. Acknowledging uncertainty. Oh, I didn't have time to talk. We've done all this research showing that if you do own up to uncertainty, it doesn't reduce trust in the source. Preempt misunderstandings. My personal impression that media coverage tends to reflect the original comms from the organization. So if you do the comms well, it will be almost always reported well. It's your responsibility. Don't blame the media. Well, I mean, sometimes you can blame the media. Sometimes they're awful, but usually it's your fault if they've got it wrong. But this needs attention and training and care and scrutiny. Okay, just to show about statisticians and the media, You know, I may moan, but I've had a bit of fun with this. This is a bit of fun I had with this. I was on, this is December 2020, on the Today programme. I said that just before Christmas, they asked me about this, and I can't stand answering these sort of questions, so I thought, oh, let's play around a bit. I said that raised voices could spread the virus, so maybe singing would be banned. In fact, like my choir, yeah, we had to sing outdoors with masks, you know, 2 meters apart. We still did it. And then I was feeling a bit mischievous, so I said, well, it might also be a good idea to ban family arguments, because there's nothing like, you know, shouting at each other over the Christmas unventilated room, super spreader event. Anyway, this was a joke. But I couldn't have hoped for better. Daily Express, Christmas warning, families could be banned from arguing to prevent COVID spread, according to a leading British statistician. Thank you. So I do felt I did my little bit for the reliable reporting of COVID. Thank you very much indeed.
So David has agreed to take questions. There are 2 microphones here. Just raise your hand.
Is this working? Yeah. You mentioned getting the balance right and not having a false balance. And one of the things I certainly observe in the media is a tendency to convey balance by giving equal voice, even though one side is patently fake media. And that seems to perpetuate fake media and even build it up. Is there any way of persuading media to get the balance right rather than equal?
Yeah, it still happens. I mean, I think that the BBC got such a bollocking on the climate change stuff when, you know, when they're putting up, you know, Lord Lawson against somebody who actually knew what they were talking about, as if these were two equals. And Steve Jones and previous speakers also had a really good. So I think the BBC, who are, you know, they regulate, they do have to be balanced, have realised that it's not when it, you know, and it's clearly a huge imbalance in terms of what people believe, what the people who know something about it believe. It's not 50-50, and they've stopped doing that on climate, you know, notice. They're still accused of doing it in other areas. For example, I don't know, economists on Brexit or something like that. So it's not completely dealt with, because they are legally obliged to be balanced. But that does not mean 50-50. And I think that has really been recognised now, and I think they try to be careful about it. But it can still, I mean, what I say about all this stuff is complain. Complain to IPSO, the press regulator, if with inaccurate headlines, complain, you know, just complain. Yeah.
Eric Aitman.
Thanks. One of the sources, I think, of confusion of statistics is very small probabilities and comparing very small probabilities. Like, you know, chance of such and such an illness has doubled from 3 in a billion to 6 in a billion.
No, I usually use a relative risk and absolute risk example in, you know, is one of my standard examples. But you know, I usually use bacon sandwiches or something like that. So yeah, just because the risk has gone up, it doesn't mean that it's important, because it probably wasn't very important to start with, and now it's just a little bit less unimportant. So yeah, I always say, you know, twice not very much is not very much. Yeah. So again, these are basic tricks that people will use. They use relative risks or the absolute risk to manipulate the story. We've got a whole program now, Real Risk. I do recommend it for journalists and press officers who will take a relative risk and rewrite the story in terms of absolute risks and show the graphics and things like that. Terribly important, I think. Yeah, yeah.
I saw some hand going up there. Yeah.
Good evening. Thank you very much for the time. Out of curiosity, as a media consumer, how do I protect myself against this?
Yeah, no, that's not the talk, I deliberately didn't deal with what can you do about it, because it is terribly important what questions to ask and things like that. Tim Harford's book is extremely good on this, the questions to ask when you hear a story. And he starts, which I think is very good, on is ask yourself, how does this make me feel? And I really like that. I thought, what did he say that for? He said, yeah, I really like that, because rather than thinking, oh, can I believe this number, and analyzing this type of study and things like that, the first thing I think you've got to ask is, why am I hearing this? Why is somebody telling me this? What are they trying to do? What are they trying to make me feel? Who is trying to manipulate me by telling me this story or the way it's presented? So without even looking at whether the number's believable or not, you first think, what is the motivation behind me receiving this piece of information? Why am I hearing it? The more difficult thing is then to think, what am I not hearing? What am I, I'm getting a story, if they just selected something, what am I not hearing? That's the dog that didn't bark in the night. That's much more difficult to identify. That really takes a lot of skill. But you can, I think, start thinking about, and essentially what that's saying is, how trustworthy is the source? So I think number one question is the source of this trying to inform me or persuade me? So I put that as the number one question to ask. And we could talk for ages about how can you get this kind of stuff, critique, into the educational system. It doesn't fit very well. It's not really maths. It's, these are personal skills. It's identifying false information on social media, something that, every young person should be skilled in. But quite difficult to get into a school curriculum.
Gentleman down here, and then the gentleman down there.
I'm just wondering if you think it's dangerous for having non-zero baselines on graphs, where you have sort of 0 to 100, or instead of 0 to 100, you have 91 to 92, where things. How dangerous can that be, psychologically?
Terribly. Yeah, no. I mean, one of the problems is, and obviously one should try to use the whole scale always. But if all the numbers, they can make the graph unreadable. If all the numbers are varying around, 93, 92, something like that, they're all squidged in and you can't see them. So there's always a trade-off, I think, between the interpretability and the misleadingness of the graph. So, I mean, the standard way would be to put in 0 and put in a jaggedy line to make it clear that you've jumped that, or to use multiple graphs. But it's similarly like, do you use a log scale or a natural scale? They've both got advantages. You should use both if possible. But I've got a whole, as like usual, a lot of manipulative graphs where people have chosen the axis in order to make something look big, which doesn't look big. So there's no absolute correct answer to this, because what do you choose as a baseline to make the graph readable? I mean, what axis do you choose? You really have to think, there's a lot of self-reflection there, I think. Is this going to manipulate somebody? You want it to be readable, but you don't want to force a false interpretation on it. Tricky, if the numbers don't vary very much. Yeah.
Gentleman in front, yes. Last question.
Paul Hudson, thank you very much, Professor Spiegelhalter, for another illuminating and entertaining talk. I have the impression over the years, being an old git, probably influences my opinion, there's been increasing distrust in government in this country. My friends, particularly in France and Germany, seem to get an increasingly bad impression of British government. And I wonder, A, whether in fact there are people within government, notably civil servants, who are worried that, that ministers and others are manipulating or being selective with statistics. And B, if that is happening, has there been an increase in giving you this information that you think that manipulation is in fact being used?
That's really good. And of course, now I have my big conflict of interest because of my work with the UK Stats Authority. The trust in British official statistics has never been higher. It's really very high indeed. Which is really a good thing to know. So that's partly because I think British statistics, they're not part of they're not under a minister. It's a non-ministerial department. It answers to Parliament. So although it is, in a sense, it's part of the civil service and everything, but it answers to Parliament, not to a minister. And I think that was in the 2007 legislation, which has been an incredibly valuable thing to do to retain its independence. And part of that legislation also is to have this Office for Statistics Regulation, which is the watchdog, the regulator, that tells off politicians when they misuse stats. And they do tell them off. A lot of it's behind the scenes, because you can't constantly have these confrontational aspects. But now what you're asking me is actually, I wonder if there's been, and a lot of that is responding to public complaints. So again, if you see a minister or a government misusing statistics, complain to the Office for Statistics Regulation. Really complain. They take a lot of notice of these. And some stuff gets a lot of complaints coming in. Now whether, the problem is that, statistics, whether those numbers have gone up, in other words, there's more false claims by ministers, is tricky. One of the problems is that, I mean, when you've got Boris Johnson there, I mean, he's one person, little, not more than just a blip. There he is, constantly lying in Parliament about fewer people being unemployed, and so, or employment going up, which was wrong. So it was it's quite difficult to monitor the numbers of cases in that way because they come in tend to come in big clusters. I don't know whether it's got worse because politicians have always misused statistics, always. But now at least there is a system to hold them to account. And so everyone should use it if they can.
Thank you. I'd now like to invite Professor Danilo Mandic of our department to propose a vote of thanks to our speaker.
So, good evening, everyone. So, my name is Danilo Mandic. I'm a professor here at Imperial. I specialize in areas which fall under the umbrella of machine intelligence. Statistics is the backbone. So, as one famous motivational writer once said, feeling gratitude and not expressing it, not being able to express it, is like wrapping a present and not giving it. So I'm delighted to be in a position to give this vote of thanks to Professor David Spiegelhalter. So the talk was outstanding and addressed an area which is known for its complexity. Throughout his career, David Spiegelhalter has been on a mission to demystify things that are difficult to explain and make them look so evidently simple and patently obvious. Thank you for that. And not only that, he possesses his own brand of creative thinking and clarity of mind when communicating, so which he uses to shed the light on even the darkest corners of the understanding to the benefit of all of us. So some of you in the audience are in a position or will be in a position to make decisions and policies based on statistical data. So next time, maybe think a little bit about this evening and this talk. When I looked around the audience, they all seemed to be captivated by your talk. So your examples were truly stunning, and you provided a number of ideas for our audience to take home and implement in their private and professional lives. So perhaps for inspiration, you can start from the latest book by Professor Spiegelhalter, COVID by Numbers. Please look at the subtitle too when you read his work, because the devil is in the subtitle, in the detail. So it's been very much a privilege to all of us to listen to you this evening, David. On behalf of myself and all 1,000 of you, both here in the audience and those online, let us give Professor David Spiegelhalter a loud thank you. Thank you. Thank you very much.
That concludes the evening's activity. Thank you for taking part, whether in person or online. Thank you. All right.